unique in that it's actually his departure into biomedical informatics, something that I will learn too. So,
okay, thanks, Tekken. I really have been doing, many different things, and this is an opportunity actually for myself to think, where I have been coming from and where I'm going. Sometimes you get too busy and you don't look back and you don't look forward and you just do what you're currently doing. So, this talk will serve several purposes. So one is the kind of profile of the project. The other is the kind of view that I have personally gained over this experience about the relationship between research development and development research. So I changed the title slightly. As you can see, it doesn't match with the original announcement. I thought this would be a better title to capture what I want to say here. The transform. I mean, if you look at the industry and even universities, and the current state is different from 20 years ago. It's not that you do research for 10 years and find out what's available for commercialization. It's actually you do the development and find out what kind of research is needed to make it work, and you go backward from development to research. So I'm trying to capture some of that from my own experience as well. Myself, I use, as Tekken mentioned, I used to do theory a lot, including automata theory, programming language semantics, formal concept analysis, and logic for reasoning about programs. And my activity, or you can roughly estimate the kind of activity or effort by looking at the two curves, very roughly, so this would be the development side, including software. The faded line is the theory part. It's slightly declining, but I'm trying to maintain activity in that as well. So the pick is on the actual. I had 5 years ago I had no experience in developing any software system. It's like learning through practice, and so I'm gonna tell you some of the stories behind this development. And actually, the change point, what triggered this is in 2003. We had a new chairman, Mehran Miragani, and he put me in charge of a project that for taking only undergraduate students to revamp the department website. And that time the idea was, where if you had a clean start, what would be the idealized setting you want to create a departmental website that would be useful for everybody. And that was a starting point. And Mehran coined this term knowledge platform, but I don't think we got very far in the knowledge side. But it was a good experience that actually initiated many other activities in different directions. One of which we're going to focus is this MultiModality, MultiResource information integration system. And that actually started a year after. And then some of the issues that Tekken also mentioned, information retrieval, ontological engineering. That's other part of research I currently do, but it's not so much related to MIMI yet. We'll see where.
What is the vertical axis in that?
Which one? Oh, it's vertical. It's sort of activity, intensity of activity.
Okay.
Yeah, I just.
It's the highest.
5 is the highest. Yeah, it's a rank of activity, perceived activity. Here is the snapshot of current MIMI-related activity. So this system has been deployed at the Imaging Center since 2005, and Proteomic Center, but microchance since 2006, and flow cytometry, it's currently being deployed. CTSA request management system is implemented based on MIMI technology, and the lead developer is Jacek Szymanski, sitting in the audience here. And at Hoyer Swedlock Center, they have 25 million grant, third frontier grant, started a couple of years ago, and they learn about the system. Now we have an instance for managing their the high-end instruments in their center. Then there's a recent PhysioMimi NIH grant we just received, and it actually started just a week ago. And for this, we're going to build multi-site information sharing for sleep research data. And that's also based, where part of it will be based on Mimi, and the other part will be actually the analysis and the privacy, those kind of issues, and access paradigm. Which one? Do you build a data warehouse where everybody contributes the data to a centralized location, or do you allow some sort of distributed access that you have a central kind of query interface that translates to local stored databases without the actual data moving to different systems? So these are the issues that will be addressed in this project, where as a result of this activity, we had several posters, several papers, and one PhD dissertation. That's actually by Jacek. So why are we doing this? So when I started collaborating with biomedical researchers across the campus, or on this side also in the biomedical engineering, one of the challenges actually they face is that before getting to image analysis, before getting to the detailed proteomics analyze tools, they actually have a more basic problem that they're facing. That's from the facility managers keep telling us, and we observe that, is that you have these costly instruments, but how do you manage them? Because these instruments are not single PI owned. You don't own a $2 million instrument and then just do research by yourself. It's shared by multiple people. And then the model, the kind of, if you say, business model is that you charge the hourly fee on those instruments, but then you need to get the data over, you need to schedule without conflict, and you need to report the activities so that you can justify what's been done and where are the further resources that are needed. So these are the aspects. So just to get the flavor of the magnitude of the problem, here are some of the imaging systems in the imaging center. These are, if you see a high tesselar level, that's animal. This kind of system have not been approved on humans yet. So this mostly rodent, mouse, and sometimes dogs are scanned. This is 7 tesselar MR system. This is the high fidelity 9.4. This is one of the most advanced imaging systems in the center. Then there's micro PET. The combination of SPEC and CT. This is manufactured by Gamma Media, and tons of other additional systems, including, let's see, there's a cryo-imaging, there's fluorescent imaging system. So to summarize, the imaging facility has over 9 million worth of imaging systems. And to host this physically in the building, there's a $2.7 million investment in renovating the sub-basement in UH Hospital to accommodate those facilities. And the lab space, 8,500 square foot of lab space for that. And currently there are 14 primary faculty members, and actually Professor Dirk gave a seminar a couple of weeks ago, and Dr. Flusk is currently the scientific director of the center and also the manager for the facility. There, those instruments that you've seen currently supports about 150 active research projects with over 200 active users. and generates terabytes of imaging data every year. The intensity is going to increase as research productivity activity increases. Okay, so let's look at the slightly different center. This is the Proteomic Center directed by Dr. Mark Chance. These are 4 of their typical instruments for studying the protein structure, protein sequences. And actually, Jacek took those pictures. And then we look at the Swedge log. These are their instruments for studying the material, structure of the material, electron microscopy. They have many different sizes to put the metal and other kind of materials in different environments and then study them, the structure. Then there's also the flow cytometry, which is one of their activities to actually you have the blood cell, and from the blood you actually the blood runs through the system, and each cell in the blood gets a reading because they have 30 channels. So you can see what kind of measurements you can get and analyze the structure of the cell based on that. So this is in the Jacoberger's lab. These are some of the instruments, and this is a blurred picture because we cannot use light in that setting, so it's harder to take. So as I mentioned, these are some of the challenges. How do you schedule on those instruments? How do you manage a project that's studied on this? And how do you track samples that's being studied? You have, in order to get data, you have to have sample in, then data out. When data gets acquired from system, how do you handle the data actually to the investigator who needs them? And how do you let your collaborators also look at these data? So there are many different kind of issues. Last but not least, here is a statement and billing. After the investigators used this instrument for their study, then you have to keep track of what's the material cost, what's the time cost on each of the instrument, and also generating using user usage report for based on each instrument, based on each project, and based on different things. You can set different criteria. So so these are some of the questions that arise in the practice of shared resources. If you multiply that by 17 times, you get into a center setting. This is the Case Comprehensive Cancer Center, one of the 30-some NCI designated cancer centers. So at the center level, you have yearly research expenditure is about 150 million. And you have hundreds of projects and 9 scientific programs and over 350 active members in the center that uses the facilities in each of the 17 cores. Okay, so that's a magnitude of a problem that we're trying to address. And so the MIMI system is aimed at developing a comprehensive, a single system that tries to address all of these aspects, so that you don't need to switch from one system to another and use Excel or Outlook Express to manage the schedule and things like that, where you have multitude of problems, data inconsistency, update, and people know that. So the goal is we want to have a web-based system, facilitate the use of resources by investigators in a structured way based on projects and roles in an organizational structure of a center. So here are some of the key properties. It integrates this administrative support with scientific support in one system. It doesn't separate them. So billing and accounting is the same system as scheduling and data access. makes resources visible, their usage manageable and reportable. Once you have those integrated information, then it's much easier for you to gather all of these different activities just by a click of a button. And then once you have those, then actually this is one step forward. And actually we're thinking the system is moving in that direction. Once you have the different facilities sharing the resources and sharing the data, then what one investigator had, let's say, a tumor tissue studied in proteomics and tumor tissue also studied in imaging center, then they can cross-reference and see where data have gone and following a single patient. But the single patient, the sample has been studied in many different cores and link those data together. And that's the bigger picture in the scientific direction that we're actually driving. So the system name MultiModality, that means that in one system we do many different things. Here are some of the key tasks that you can do. You can manage the scheduling of resources. You can manage projects and studies. So you can create new projects and create new studies under each project, and then schedule sessions under study. Manage user profiles and roles, that's at the center level, administrative level. Update, archive, and download data. Generate summary reports on the fly. Generate statements for different purposes. And you can also manage project team who you want to be able to access your data and share your data. And you can actually designate somebody else to do some of the management for you because, for example, Mark Chance is the director of Proteomics. He's so busy, he doesn't actually get to the system and do many different things. He instructs somebody else and he trusts to do this. So you can set up those proxy. So the approach here is actually learning from practice. So this paradigm, the developmental paradigm that we use, falls into the Agile development. Agile development, the idea of Agile development is that you don't design the whole system before you implement. So you design everything, specify everything, then you implement, then you test, then you deploy. That's the traditional waterfall style of software development. Here, we actually interact with the end user on a weekly basis at the beginning to acquire the features, to understand what they need. Sometimes they don't understand what they need. We don't understand that either, but we come from different sides. They tell their story, and we can translate into the system architecture and system features. That way, then we develop the main features that they say, this is absolutely that we need this. We implement those key features and then iterate and expand based on that. So we use whatever can help us to increase the productivity, increase the usability. So Ajax is one of the tools that helps us to design the user interface that feels like you're using your desktop instead of a web application. We use open source development environment, so it's not only decrease the cost, but also we can develop the additional features. If the system does not have them, we can expand that without any restriction, without relying on the next release of something. Then either we're forced to update or the features we want are not there. Okay, so this is some of the benefit of open source development environment. I'm going to get back to the rule-based access control aspect because that is actually one of the key mechanism, framework to enable us to actually manage the complex environment without, bogging us down, burden us to the level of, interoperability. So at the high level, conceptually, we partition the a core facility. So let's say this is imaging system or a center or Proteomic Center. There are 5 main entities associated with this. There are people come in. These people are, they may be investigators, they may be administrators, they may be operators, different kinds of people. But they fall into the category of people with different roles assigned to them. Then there's the management, scheduling and accounting of all of these activities. Then there are instruments that they need to catalog what kind of services they provide by which instrument and who is operating those. And then this is input sample. Each investigator, usually they bring their sample or ship their sample to the facility and then ask the facility or themselves sometimes to perform a study based on this high-end instruments. Then that's generated data. That data you can have imaging data, 2D GL data, and different kinds of data. What we don't do, this next slides will make it clear, is that our focus, so based on the prior structure, we partition the whole system functionality into three main areas. One is the meta server, which deals with all the alphanumeric information. Basically, it's, if a catalog of instruments, user, project, all of this, and interfaced with this is also the interface where user come in. The data server is actually, usually this part is behind the firewall because when you spend so much time and effort and resource to acquire data, you better do very good housekeeping of that and not letting data corrupted, deleted, or something. So this is the part actually resides behind the firewall usually. And regular backup, those kind of discipline are applied here. It doesn't have any alphanumeric data. It's all the acquired raw data, image data, and then what we don't do, and this is a place we aware that we need to have. So we right now this is just a placeholder. So in Proteomics, they can use the Protos system developed by Genealogics and interface with that, and then have a complete Proteomics pipeline happening here. So not only data is acquired, scheduled, and here, but also analyzed and scientific report is generated here. This is something that we can't do because there are so many different varieties. We can't be knowledgeable in all of them. We let the domain experts to deal with that. So toolbox and things like that happen there. So if you look at the MIMI actually consists of these two components, but we provide the interface to link to application server. Actually, the user management can still happen there through the same front end. Where, as I alluded to, this is actually a draft of the Case Comprehensive Cancer Center's informatics infrastructure diagram, where actually MIMI sits on the top left part. So, so we have the access front end. This is a meta server. This is data server, but then it's designed to have interfaces with biorepository and also a clinical trial database, so that the vision I mentioned earlier, where a single patient comes into the system, can get their tumor tissue analyzed in different facilities and actually generate reports. And from this biorepository, you can also query for which patients are suitable for which clinical trial study. So they can do screening based on this. They can do retrospective study based on this as well. But MIMI provides the scientific side and the access side, and this is all happen in the more clinical side. To access those data, you need to have a human subject's clearance. So you need to take a test and study some of the basic regulatory requirements about that. Yes?
So the biorepository is implemented, that is data in queryable form now?
There's a couple of pilot projects that can be queried, yes. But we have not, so the next phase would be the integration, because for that query, they just, you need to be basically the administrator root user, and then you do the query, but it's not handed over to the end user from here that they can select what kind of resource they can set the query form and then do the query. That must be a wrong number. Oh, I have to ignore that for now. Okay, so there are a couple of pilot studies to see what kind of integration we can have, and what needs to be done there. But that's where that's in collaboration with the University Hospital Pathology Department, and also brain tumor study. They have a center there. So this is just one slide where everybody can understand. This is just abstraction of a lot of other details. That a very basic first step is to do this data modeling. So this is actually acquired from the end user, and we sort of abstracted this out so that it can be applied to different facilities. There's for what amounts to a project, what is a study, what's a grant, and what is a session, what is a service, what's a facility, what's an instrument. So these are actually where defined in the system, these concepts. And and a session is actually a realization of a service. A service is provided by one or several instruments. Sometimes you can do something with, at the high level, but then this service can be provided by different instruments. It doesn't, some more costly, some less costly, and sometimes the end user doesn't know that you don't need, $500 per hour instrument to do your study, because even if you get those information, it's not going to be helpful for the aims of the project. Okay, so here's a snapshot of the role-based access control interface where we can look at more about this, but there's one step forward. In here is that we use administrative one, so that in the traditional sense, role-based access control is that you have users. Users can assume different roles, and different roles are associated with different permissions. But in the large and complex environment, such as the Case Comprehensive Cancer Center, just to manage the roles and the users will be a lot of work. So one thing MIMI does is that we actually delegate the management of the roles to different facilities. So the role assignment itself is a permission, okay? So that's administrative role-based access control. So we can hand over to Chris Flusk, and he can then designate different users in his center to different roles. Who is going to be the operator for what instrument? Who is going to be able to approve schedule? Who is going to be managing the PIs that's permitted to get requests from their resources? So that can be done. And in this way, we can have the system really more scalable, and we're not going to be bogged down. After deployment, we actually don't get questions back from the facilities because most of them are handled on site. They don't need to get to the developer team to be able to address, unless it's a feature upgrade, unless it's a system reconfiguration and those kind of things, we step in. But for the daily operation, like Imaging Center, they have been in operation for more than 3 years, and we have never had calls that say, oh, this doesn't work, that doesn't work, and can you help me with this? We only get twice of a feature upgrade since deployment. Okay, so that's all about the high-level overview of the MIMI system, and I'm going to let Remo, is Remo here? Remo is going to give a live demo of the system, and you can see how the system handles the different tasks, and you can ask, how do I do this, how do I do that, and we can try to accommodate that. This, we have two different sites. One is the developmental site, testing site. The other is the deployment site. So we're going to use the testing and development side first, so you can actually put schedule there and doesn't mess up with the real data. But if that doesn't work, maybe we have to switch to the deployed side just to show what kind of data and what kind of projects are there. So Remo, you can use the laptop here and PC here. If I don't know if it works. You can also bring your. It's probably easier to use yours, because if the network fails, then you have your own instance at the laptop, right?
So we'll just plug it in here.
Do you have your adapter? Yeah. And so after Remo finish this, if there's still time left, I'm going to talk about some of the research aspects. Remember, the paradigm is from research to development and then to research itself. But this research is more developmental driven, so that gets us to the topics that we never would have gone ourselves without motivated by the system. You don't have?
I can always just use the Safari in here.
You can also, let's see, we can see if the wireless works here. If the wireless works here, then that's, I don't know if the wireless system works, Okay, you can try to see if it works. Okay, yeah. Good. Well, I can hand over this microphone to you.
Oh, okay. All right, so this is the our live testing site at the moment. So I'm going to show you a couple features of the program that we've been working on. First of all, we've integrated it with the multiple login systems, so you can use the case ID. So I'm just going to log myself in. I'm currently the system administrator. There we go. So I can basically do anything I want in the system, like read, write, make new equipment, make new services. To make it a little bit more interesting, I'm going to show you the proxy system that Professor Zhang was talking about. Basically, what the proxy system allows the system admin to do, or any other user, is to act as another user. So I can limit what I can do or enhance what I can do by acting as different users. Since I'm the system admin, I can have everyone's, but other users would be able to assign other users. For instance, a principal investigator. All right, so I'm going to log in as a facility admin. And the first thing we get here is our dashboard, which basically shows us how we can set up the facility. So I'm currently in the proteomics facility, which you can see already has a couple things set up. We have equipment set up and we have services set up. So, for example, we have these specific machines to the proteomics facility that actually exist on the campus. And then we can also look at the services that are available to the users. And so here are a couple services that the users can actually run. So if we'd want to make a new service, we'd be able to just click here, say, if we wanted to do a cell sorting service. We can set other options that would basically change the way that the service acts in the inside of the program. We can set a price. We can add operators to it. So the operators are basically people who are allowed to complete the service for the user once it's requested. And then we'd be able to say which machine it's going to be working on. So we can add 2 of these machines. So now the service is created. And at this point, we've pretty much set up the facility. The only thing left is really workflows, which is basically a series of services. So if you have some very complicated workflow of things that go across machines, you can basically say, OK, I'm going to make a service workflow that goes from this service to this service to this service. I'm just going to log into the production site to give you an example of one of these. Because Proteomics uses these a lot, so if we take a look at it. For instance, this is the double-labeled gel workflow, and it goes through these services. So when you're actually scheduling the service, you can say, I want to schedule a workflow, and then it'll automatically populate the list with the services that are given. That's just one quick example. Oh, and if you have any questions, feel free to stop me. So the next thing, the most important part of the system is basically the end user who's actually scheduling these pieces of equipment. So I'm going to log in one more time as the principal investigator now. So this principal investigator has already set up his own study and his own project under the study. There's also a couple of users within the study. So we have 2 users that are actually running on it that can also schedule services. So here's part of the scheduling interface. You can click request. Click what study we're going to be actually requesting the service under. And then we can say, I'd want to do the affinity separation and the intact, these 2 services. So you can request them. And at this point, this passes it back to the facility admin to actually approve these sessions. The Proteomics facility is set up so that the user can't actually schedule the time, but that can actually be changed based on what the facility admin wants to do. That's why I didn't actually schedule anything there. So at this point, the facility admin gets notified that someone has requested a service. So we have something that we can approve. So we get some information on it. And now we can say, all right, these have been requested. You can set the operator for them. You can say, okay, I want to do this one on 8:30 to 10 on this day, and I want to do this one over this period of time, and just approve it. So the process is almost complete now. The only thing that is left to do is for the operators to log in and to complete the sessions. So I'm going to log in one more time. So the operator now sees that he has a session to complete on this day. So he can just click on it, see any previous tasks that have to be completed before this task, since any workflow that you set up has to have the steps done in order. He can see that this one's actually still hasn't been finished at this point, but he could finish his own part and say, I ran 10 samples for this, and basically complete the session, at which point the session becomes completed and the facility admins and the center admins can actually invoice the PI of the project who scheduled the service. So that's basically how it goes from setting up the service all the way through completing it and invoicing it. So we also have invoicing feature if you want to see that. Any questions up till now?
I noticed when you're scheduling a time slot, it's like it tells you to like drag over any amount of time. Is there any way in there to say, when you create the procedure, say that it's going to take an hour and it automatically schedules time slots in increments of 1 hour or whatever? Or do you have to manually?
We don't have that at the moment. It wouldn't be hard to add to it, but we haven't had it requested yet. So we just usually add features by how many people are, like, we basically prioritize the features that we have, and then we'll work on the ones that most people want.
So the smallest time increment is 15 minutes, right? You don't
I think it's
yeah,
I think it's 30 minutes.
30 minutes, okay. So it's close to, we don't differentiate anything smaller than that, yes.
Actually, I really would like to see more about the architecture, the implementation, and the components, as opposed to seeing these features. I mean, any system now have this kind of features. So this is not any.
Okay, so we can switch back to the I can switch back to some of that aspect of the the development environment.
For this audience, that will be more.
Okay.
Formal.
We can also switch back to this if anything there that. So right now we have. Oops, it's too much. So we have finished where we have suspended the demo part and get to. So this development environment, we use Ruby programming language, Rails framework, and the ModView Controller pattern. Here are some of the other pragmatic features, some of research features that we actually use, deploy during the process. So I'm going to touch upon some of this. Ruby, many of you probably already heard about. This is a pure object-oriented programming language. Everything is an object, and it has it can compile. It has also interpreted versions, so you can interactively develop your program and get instant gratification or instant annoyment that if you need to run. It's actually simple and elegant. It has many other features.
Does it have a compiled version?
Yes, it can compile. Yes, it does a compiled version too. Some of this can only be shown by actually some code examples. So here I actually got some screenshot of the interactive version. Enumeration. This is a screenshot of the feature of enumeration. You can say you want to create an array where you can enumerate from 1 to 10, but convert that to an array. Okay, so you get 1 up to 10 right away. And then you can perform this operation on each element of the array, either in place or create a new place. So this collect is the a.collect is create this operation for each element I. You do the square of it. Okay, you get everything squared in this. You can put exclamation mark here, and that will do it in place. So the a itself will be changed to this. The prior one that doesn't change a, this actually does it. It change the elements in a itself. So this is just one, and here you can do, this is very reverse. So you can read it, much easier. You do 5 times, do this, and you get 5 times that. 5 dot times, because 5 is an object, times is a method associated with that object. And this a is an object. Anything is an object. Anything you write, you can put a dot there and access its method. And actually this, can you see this? You can actually, so this is, can you see this? Okay, so this illustrates 2 things. One is reflexive. It can ask itself, who am I? And answer. So this is what type of things am I? So this is actually range, enumeration side. You can also put dot and dot, sequence of dots. That's composition of methods. So you get from the range type to array and ask, what is the class now that I got? And it's array. So it actually does the reflexive thing. And this is the most interesting thing that actually you can say where math is a class. Okay, so what is the class for the math? It's actually module. Module is a package of objects and methods together. Then you can say what are the methods associated with the math module. Here are everything you have. You have cosine, log. Some of this tangent, arctan, and tangent you can send. So here are all the methods associated with this math class. You can just put a dot methods there. You can see everything that's accessible. All the methods associated with this module. And if you have an object, you can put the method there, and it's all the. You have to have a module to do this. So this is an introspection. These are just some of this design consideration with Ruby that makes it the programmers like it because it's so intuitive. And you can do one thing, you can do many different ways also. It's very flexible. Actually, Ruby didn't take off after 5 years since, I think it's 93. But it's the Rails web application development that actually populated the idea. And the merging of these two, ModView Controller, web application development environment, with Ruby's object orientation, this coupled together actually generated, so that's a killer app for Ruby. Used to be, there are only two, like if you're 3 or 4 years ago, there are only 2 books. There are lots of Java and other things. Now, if you check Amazon, there are about 400 books. And some of those listed here are the ones that's to be published next year. There are many, there are 11 or 12 books already in the pipeline. So it's definitely gaining popularity, but also our experience has been, when we implement different versions of Mimi, we use the different system. We use the Plon, Zope, Plon, the first version. We use the Google WebKit for the second Proteomics version. Now we say we want to implement Mimi 2.0, and what would be the good environment to develop that will sustain us and increase our productivity. And this has been proven to be very effective, and that's why we can have the different versions deployed and be able to satisfy some of the development phases and speed actually quite satisfactorily. So this is a very simple ModView controller. This is a developmental pattern. So when you have a development environment and a complex one of the top level things is to find out where are the programs that does such and such. Where do you find those? You want to modify it. And for other component, when you need to access some other features, where do you find that program that does this? The system. So ModView Controller is actually nothing more, maybe slightly more than partitioning of your development environment into different directories, so that each directory addresses one aspect of it. And so when a request comes in from the website, going through the routine, and so this is a controller part. Controller decides that where it needs to access the database. Where database is not accessed directly, it's through a mapping, so that the database table, the schema is a class. Each column is a method. Each row is an object. So this is a generated, but the Ruby does this mapping, active record mapping, very well, so it's highly usable. Basically, what happens here is that a programmer can program in very high level, and the system translates those into MySQL, other kind of query language syntax, and access the required database component. It's a translation in this way. And then after the data is obtained, then decides which kind of data, what view to present to the end user. So this is the ModView controller. Basically, these 3 parts addresses, there are 3 high-level directories in the development environment.
What's basically active record model? Is that the one that we say each row is an object, each column is an
That's the basic, yeah. That's
the active record model?
That's actually that's embedded in this translation there. Yeah. So that's what I've just said. What's the object, the relational mapping? It's an active record. But this Ruby on Rails development environment has something that it's not academic, it's not research, but it's pragmatics. So it has this philosophy of convention over configuration. Remember, when you set up the system to work, you have complex configuration file, which variable means what, and things like this. This eliminates as much of a configuration as possible. You do things by convention. You capitalize things, and that becomes class. Lowercase of the same thing becomes an instance. Okay, and local variable is an @ sign in before a string. Global variable is like 2 of the @ signs. I maybe confuse this too, but so by looking at those, you don't need to declare a variable, and you don't need to say this is local, this is global. By looking at the syntax, you can recognize that, and this is all over the place. So I'm just giving some of the examples here. So that's why you save a lot of time in your actual development. Another aspect that we are actually learning also is this thing called restful representation of a state transformation. So it's a way, it's again another pragmatic side that you cannot really write research publication about it. It just allows you to do things in a much more cleaner way without repetition. You don't repeat yourself. So that look at, you want to get the article, you get the article, but you want to post article, and that becomes, you translate that into create. But then if you already use the post, you should understand that it's already create. If you want to update, it's put something there. If you want to destroy something, you use the delete, the same syntax here. So by reading this URI, the system, both the system and the developer and the user can already get an understanding of exactly what are the objects that gets updated and what's action you're performing on it. Okay, so this is actually one alternative paradigm to the service-oriented architecture, where you send messages around. This is not, you don't send messages around. You pass this, and it translates into appropriate actions. Here is one of the examples. Somebody did a comparison of if you did the same, develop the same web application using Java instead of Rails, what are the differences? Assuming both are competent developers. Here's where this is the most of the saving, because Rails have the convention over configuration. So instead of over 1,000 lines of configuration, you only have 100 of configuration because you don't need the rest of it. The other also number of classes, it's reduced. The number of lines of code is a third. So that once you're familiar with this environment, you increase your productivity. One thing we did that has been impressed or is going to be published soon is the interface. When we have this complicated system that you want to ensure only the person who has the authority to perform some action sees the action, like the drop-down menu in the system you've seen. Some of them are reporting, some of them are creating projects. You don't want to have everybody to be able to generate reports, only the authorized person. So how do you make sure the menu displays exactly what the user can do and not anything that the user cannot do? Because if you see something there, you assume you can do it. Because otherwise, you keep clicking it and nothing happens, and that gets frustrating. So we used former concept analysis as a way to help us design this the user interface, so that we have this, what you do is really what you see. So what you see is what you can do.
But this is independent whether we use Ruby or Rails or...
This is a methodology, yes. This is, I'm getting back to the research side from more. So this is actually our, so this is a research paper. And actually the basic idea of this is actually simple. You first analyze from the roles to different permissions they have, and then you get you get a diagram like this. And diagram determines a hierarchy, and attached with each one you have this kind of actions you can perform. Then you can map those high-level actions to low-level methods. Again, one level further. And now in the end, you want to group those different methods together to provide the users access. And you get yet another diagram that translates one level further. So these kind of lattice diagrams helps you to package different sets of operations or menus together and put there, because then we can get back actually implement this using Ruby on Rails technique called partials. So partials is like object orientation, but it's not really object. It's just a partition of the web content into different functional areas, so that you can say, I want to combine these functional areas together to present as a web interface to this person with this role. So you can combine them. Okay, and actually getting back one step further. Actually, when we look at the in more detail, there's no in rule-based access control, there's no foundation or principle, methodology for you to apply it. How do you apply it? You can have, for example, this is actually taken from one of the papers on called the rule mining problem. So when you actually engineering a website, how do you know what kind of rules you have? You can start with the intuitive ones that map to the physical or organization structure one, but is that good enough? Do you need like operator as a rule or not? These are the decisions that one of the approaches said, okay, you just map all the users, typical users you have, and say what they can do. Then from this table, one can sort of derive the rules, the most effective rules, minimal set of rules that covers this set of permissions. And you can assign each user with different rules so that all of these different configurations of functions are attached.
A role is a set of permissions?
A role is associated with a set of permissions, yes. A user is assigned to different roles, can be assigned. So this paradigm change not only helps with the user interface design, but looking slightly distance from the development environment itself, there's this methodological part that you can actually distance that, distill this idea, and actually have a foundation approach to the rule-based access control, where you can actually address the engineering and design issues in there, the practice.
Can you explain how you get that diagram from that?
The diagram, very simply, it's each. There's 3 or 4 levels of meaning. One of the most intuitive one that actually is related to data mining is that each node here represents a maximum rectangle of ones. So for example, this U4 represents everything from all the U's, collect all the U's up to this point, and this is the permissions that it has, P1 and P2. It's actually representing this rectangle here. That's a maximum rectangle. There's another node here representing this rectangle, another rectangle. For example, this one, P4, P5, P6, P7 is, let's see, which one? It's
P6, P7 is the
P6, P4, P6, 7. That's this is probably this one, yeah. So each one has a maximum rectangle in it. That's the interpretation. But then, if you intersect any one of them, you can get more. So if you map down, there's a hierarchy. So this approach, the idea is that actually the roles are concepts. The constraints are the hierarchy. This determines the constraints of which role should have more permission over the other role. Okay, so that's explained in further detail in this paper there. How to do that? And actually, we have a different way of solving one of the role mining problems that's already studied by other people. In terms of high-level structure of the system, and this is the a paper that just got submitted. So we have the role ModView Controller. Basically, that's in the background. But the key part is to determine who does what. So that's the access control. And here is the in the cancer center environment, the rules are actually parameterized, to eliminate to allow us to conquer the complexity, so that we have a uniform actually approach to different facilities. All the facilities are actually looking the same. It's just different facility. You get the different tag here, but facility has administrator, facility has operators with services. facility has principal investigators using their resources. So that's the basic component of management in terms of. So Remo already showed a little bit about the role-based testing. When you have people in this kind of environment, how do you test the system that it actually does what you intended to do, especially in the user interface environment? Thanks, Zhang. So that proxy mechanism allows you to quickly switch different roles and see if something you intended to happen, did it already happen? There are other topics that that's going to be either emerge or being studied from this environment. Okay, so anyone, if you're interested in learning more, you can talk to me. Email me or Remo, and we can give you more in-person demo or anything, any aspect of it. And I'm going to offer a course also if you're interested in learning Ruby on Rails. That's going to be in the spring semester. I just learned that it's actually on the register's website. For those who visited before, it's now on. And I want to acknowledge those collaborators here. Some of you, Jacek Van, you're in the audience here, and other collaborators from medical school, from BME, and actually some of those are administrators there. Thanks. That's it. Any
questions? Okay. Really interesting.
Thanks.
Okay.
Yeah.